When we think of the age of dinosaurs, our minds often conjure up incredible images of a world ruled by giants. We picture the mighty Tyrannosaurus rex stomping through ancient forests, the long-necked Brachiosaurus reaching for the highest leaves. But then, we look to the skies of this prehistoric world and imagine enormous winged creatures soaring overhead. Many of us call these magnificent beasts flying dinosaurs. It's a term you hear in movies, see in children's books. You might even use yourself. It seems to make perfect sense, doesn't it? They lived alongside dinosaurs. They were reptiles, and they flew. But here is a fascinating secret from the world of paleontology. That popular term is actually not quite right. The truth is, the most famous flying reptiles from the Mesozoic era were not dinosaurs at all. They belonged to a completely separate, though related, group of animals. This might sound like a small detail, but it's a crucial distinction that opens up a much richer and more accurate story about life on ancient Earth. It reveals that the world of the dinosaurs was even more diverse and complex than we often imagine. There wasn't just one dominant group of reptiles, there were several, each conquering a different realm. Dinosaurs ruled the land, but the skies belonged to a different dynasty of incredible creatures. The creatures that soared through the skies while dinosaurs walked the earth were called pterosaurs. So if the giant winged creatures weren't dinosaurs, what were they? They were pterosaurs, flying reptiles, close cousins to dinosaurs. Imagine a family tree of ancient reptiles, dinosaurs on one branch, pterosaurs on a nearby branch. They shared a common ancestor, then evolved separately for millions of years. That's why there are some similarities but many fundamental differences in anatomy. Pterosaurs ruled the air for over 150 million years, far longer than our species has existed. They were a stunningly successful group. One famous pterosaur, often mistaken for a dinosaur, is Pteranodon. Pteranodon means wing without teeth. It had a long, toothless beak, much like many modern birds. Its wingspan could stretch up to 23 feet, wider than many small airplanes. It lived in the late Cretaceous, soaring over the shallow seas that covered the middle of North America. Its most striking feature was a long, bony crest extending backward from its skull. The wings of a pterosaur were truly unique, not like birds or bats. A pterosaur's wing was a leathery membrane called a patagium. The membrane stretched from the side of the body to the tip of one incredibly elongated finger, the fourth finger. Imagine your own hand. Now picture your ring finger growing several feet long with a giant flap of skin attached to it. That wing structure made them powerful and efficient flyers, able to glide long distances over the open ocean in search of fish. Fossils show large breastbones where powerful flight muscles attached, similar to a bird's keel. They also had hollow bones, making their skeletons incredibly lightweight, essential for flight. If Pteranodon was a giant of the skies, then Quetzalcoatlus was a true titan, a creature that pushes the boundaries of what we thought was biologically possible. Named after the Aztec feathered serpent god Quetzalcoatl, arguably the largest flying creature of all time, it lived at the very end of the Cretaceous. It shared the landscape with Triceratops and Tyrannosaurus rex. Quetzalcoatlus's scale is truly mind-boggling. So how big was it? Conservative estimates put its wingspan at about 33 to 36 feet, the size of a small jet, the size of a World War II fighter plane. Wings as wide as a school bus soaring overhead. On the ground, standing on folded wings and hind legs, it matched a modern giraffe. Peering down from over 18 feet, it had a long, stiff neck, a spear-like beak over 6 feet long, not just a flyer, a walking, flying behemoth. For years, scientists thought it was a marine glider like Pteranodon, but fossils were found far inland in Texas, in landscapes not near big bodies of water. That sparked a new theory, a terrestrial stalker. It walked the plains on all fours, using folded wings as front limbs, like a giant terrifying stork. It grabbed prey, small dinosaurs, lizards and other unfortunate animals, a top predator for its size. Then once airborne, massive wings allowed long, efficient soaring. Now that we have met the pterosaurs, the non-dinosaurian rulers of the sky, it's time to turn our attention to the actual dinosaurs that took flight. Yes, there really were flying dinosaurs, but they were very different from the colossal pterosaurs. These flying dinosaurs were the ancestors of today's birds. They were a specific type of dinosaur known as theropods, the same group that includes fearsome predators like Velociraptor and Tyrannosaurus rex. But the dinosaurs that evolved flight were on a much smaller, more delicate branch of this family tree. They were part of a revolution in the dinosaur world, one that involved feathers, flapping, and the conquest of a new frontier. These early flying dinosaurs were not giants. In fact, most of them were quite small, often no bigger than a modern crow or a pigeon. This small size was a critical advantage, as it takes an immense amount of a modern bird. Archaeopteryx lived in the late Jurassic period, around 150 million years ago, making it one of the earliest known flying dinosaurs. It was relatively small, about the size of a magpie, and its fossils show a creature beginning to move off the ground. Its feathers were advanced, with an asymmetrical shape, a hallmark of modern flying birds. This asymmetry helps generate lift, suggesting Archaeopteryx could do more than simple gliding. It likely engaged in some form of powered flapping flight, even if not as strong or graceful as modern birds. The debate over how well it could fly has been long and fascinating. Modern analysis of bone structure and brain shape suggests it was an active flyer. Archaeopteryx demonstrates the transition between major animal groups. The quintessential missing link, the transitional fossil connecting dinosaurs to birds. So, we have the giant skin-winged pterosaurs and the smaller feathered dinosaurs that learned to fly. Although they both ruled the Mesozoic skies, their body plans were fundamentally different, reflecting their separate evolutionary origins. The most obvious difference is in their wings. A pterosaur's wing was a membrane of skin supported by a single, hyper-elongated fourth finger. In stark contrast, the wing of a flying dinosaur like Archaeopteryx or a modern bird is made of feathers, and the support structure is the entire arm and hand, with fused finger bones providing strength and rigidity. It's like comparing a kite to an airplane wing. Both achieve flight, but through completely different engineering. This fundamental difference in wing structure is just the beginning. If you look at their skeletons, many other distinctions become clear. Dinosaur hips are a key diagnostic feature. All dinosaurs have a hole in their hip socket, and a specific arrangement of the 3 hip bones that allows their legs to be held directly underneath their body, giving them an upright, erect posture. Pterosaurs, on the other hand, had a more sprawling or semi-erect posture with their legs positioned more out to the sides of their body. This difference in posture is one of the main reasons why pterosaurs are classified in a separate group from the dinosaurs. Their heads and ankles also tell different stories. Many pterosaurs like Pteranodon and Quetzalcoatlus developed large, elaborate, and often lightweight crests made of bone, which were rare in theropod dinosaurs. Furthermore, the ankle bones of dinosaurs and pterosaurs are constructed differently. It's a fantastic example of convergent evolution, where 2 unrelated groups independently evolve similar solutions to the same problem. Learning to distinguish between a pterosaur like Quetzalcoatlus and a true flying dinosaur like Archaeopteryx is more than just a fun piece of trivia. It fundamentally enriches our understanding of the deep past and the incredible processes of evolution. It shows us that the world 100 million years ago was not a simple, monolithic age of dinosaurs. It was a complex and vibrant ecosystem filled with different groups of animals competing and coexisting, on land, in the sea, and in the air. Recognizing this diversity allows us to appreciate the true richness of prehistoric life and the many different evolutionary experiments that were taking place simultaneously. These amazing creatures, the pterosaurs, the feathered dinosaurs, are powerful teachers. They teach us that evolution doesn't work in a straight, predictable line. Instead, it's a messy, branching, and often surprising process. The development of flight wasn't a single event but a story told twice, first by pterosaurs, then by feathered dinosaurs. Later, a lineage of dinosaurs evolved feathers and produced the birds that still fill our skies today. The fossils of these animals are like windows into a lost world. Each fossil bone, each feather impression, is a clue that helps us piece together what these creatures looked like, how they moved, and what their world was like. The discovery of 4-winged dinosaurs like Microraptor in China completely changed our ideas about the origins of flight. The sheer size of Quetzalcoatlus forces engineers and biologists to rethink the limits of animal flight. These discoveries challenge our assumptions and push the boundaries of our knowledge, reminding us that there is always more to learn about the history of our planet and connecting us to our own planet's epic history.